Okay, it looks like we're live, so welcome back. Today, working on more admin of code. Hopefully we can get day 7 done today. Yeah, I think so. So, taking a look at what I have got right now. So, right now, I'm stuck, I get to work on the test data, get it to work on the test data, but it's not working with the actual data. And I think it's partially due to it's too large, and also, the way I'm handling the ranking. Yeah, so I can actually print this out. Do I want to do that? Maybe not. So if I go to the regular data, the test data rather, it should be right, assuming nothing broke that I don't know. So if I run it, okay, 6440, and that is actually correct. So that is working. But then on the actual input, we get some weird stuff to happen. So first of all, this number's not right, and sometimes it's different. Yeah. So it says stack smashing detected. Which isn't exactly PG, smashing the stack. It is allowed on Twitch now, though, as long as it's artistic. But basically the issue that I'm having is somewhere we're going out of bounds of an array or something similar to that. And I'm not sure where that would happen. So it seems to be happening in the sorting, which is down here. Yeah, so here's where we sort the whole thing. And the way I was trying to get it to work is by taking account for each individual value of each card. So that is what I was trying to do here, and I think that's where it breaks. So, because if I comment this whole thing out, then I think it works. Oh, I can't comment it all out, I don't think, because of how it works. So, maybe I need to comment it out here then. And then, yeah, so then this will just sort it. That's not right. This will just sort it, based on the rankings, which I did change how they work. So, this is not supposed to be like that. Okay. So if I run it now, no, it still does that. So it's not in there. Ooh, okay. I really thought it was there. So it could be somewhere else. It might just be in the regular sorting of it, perhaps. So I could look at that. Could this be breaking? It might be going forever. Let me get rid of the print statement on every print statement. Up here as well. Because I'm printing out. Let's see, where is it at? I want to comment it out because they are useless to have this one. Okay, now it shouldn't print except for at the end. Okay, yeah, so that is good. Obviously that's not the right number. It's not different now, but if I change something, then it can become different. So basically, I need to take a look, figure out where that's coming from. So could be in here. Let me print. Let's print that. Actually, that's not going to be much use. Okay, so I don't know if that was looming forever or if it was just something different. Perhaps I should look at it in GDB. Let me see. Let me print the index here. Which is actually a size key. So go print that out and let's see what it prints. Yeah. Alright, so I don't know. Yeah. It's hard to tell if it's like breaking there and then it just forces this part to stop. Or how that's working exactly. Yes, perhaps the debugger would be helpful. Perhaps. Trying to get in the habit of using a debugger because it is quite useful. To learn how to use it. So let me actually print this out. I'm gonna print something here actually. No, let me add a break here. So open up the debugger. Day of 7A. Yeah, so I'm gonna find out when that's happening. So I can do GDB, and then I want to break on 188. Maybe, and what? So let me see. Let me see what it says. Okay, and then go through all these. Okay, yeah, actually this is gonna be quite a bit. Because there's 1,000 of them. So I can do yeah, so let me just jump ahead 900 and do something like that. Okay, I think that did actually work. And then I can print I. Huh. Oh, shoot. Okay, because I need to do that actually double. Here. Okay. Alright, print I. Let's see what we get. Okay, let me do one more, like that. I keep doing it backwards. 200. Nope, it is, there we go, 200, print I. Okay, so we're almost there then. So let's see, so we go there, and then at the end, we get the stack smashing. Uh-huh. Okay. When we return from the filter. So why does it do it at the end? I don't quite know why it would do that. Let's see, what if I comment things out? So what if I just get rid of the sorting entirely? Then does it still say that? It does. Okay, so it's not due to the sorting. I want to figure out, like, what causes it, basically. And shoot, that was a lot of lag, and I don't know why. What if I don't print out anything here? I just end it after it sorts. Like, I don't think that would be the cause of it, but... okay, it is still doing that. So, I'm just going to comment out parts of the code until it doesn't do that anymore. So this, that's where we generate the matches. We kind of need that, though. I think. I'm pretty sure it'll break if I comment this out. Can find out, though. Okay, yeah, it doesn't like me using comments. Yeah, it still does that. So I don't know. I don't think I can comment this out. This will probably break stuff, but maybe not. Alright, I'll try this last one and then I'll try something different. Okay, so it actually is due to this. Something in here, it does not like. Okay, good to know. So, perhaps I could narrow it down to one specific thing. Could it be this? Yeah, this could actually be a problem. I don't even know if I need this anymore. Let's see. Okay, so it's not there specifically. But you can see this number is now different. Well, I guess I did change stuff, so that would make sense. But, yeah, I think that might be different. I don't know. Alright, let's see. Is it appending to the matches stack? Is that where it happens? No. Okay, yeah. So it must be in this main block here. I apologize for the lag. My NeoVim does not like comments. And that is not something I've figured out yet. Alright, so it is in here. So somewhere in here we must be accessing out of bounds of an array, or trying to, or something like that. And that is affecting things. And then also I think the sorting function is not right, but I want it to not say stack smashing detected. So could it be this one? I'm just looking at the places where we are appending to an array and stuff like that. Right, could it be indexing here? This could be accessing out of bounds, actually, couldn't it? Could it? Might be, it might be. Okay. That actually was, So what is the max chars? Strength slide. Do I have to do, do I need that, though? Do I use that anywhere? Yeah, so we set it in there, but I don't think we use it. Yeah, so I don't think it's necessary. I'm assuming this still isn't the right answer. Can I try it, though? Let me make sure we get the test input, and that is still correct. Because I don't think the sorting is working correctly yet. That is right. Alright, I could try it. No harm in trying, right? I don't think it's right, though. I think it's probably too large. Oh. Oh, okay. Alright, I wasn't actually expecting that to be right. But it did work. Okay, let's see what part 2 is, and let me actually commit this first. Day 7, part 1. Okay, I'm very happy about that. I thought I would be stuck on it for a bit longer. So I basically had the solution working yesterday. There was just that. Okay, that's kind of funny, actually. 7A to day of 7B. And let's get into it. Okay, so I will need to read through that. Okay, Twitch send me a notification. Alright, let's see. To make things a little more interesting, the elf introduces one additional rule. Now J cards are jokers. Oh, shoot. Wild cards that can act like whatever card would make the hand the strongest type possible. To balance this, J cards are now the weakest. Individual cards. The weakest individual cards. Okay. Weaker even than 2. The other cards stay in the same order. J cards can pretend to be whatever card is best for the purpose of determining a hand type. For example, this is now considered 4 of a kind. However, for the purpose of breaking ties between two hands of the same type, J is always treated as J. Not the card is pretending to be. Is weaker. Okay. Shoot. That could be interesting. So basically what I'm gonna do, I'm gonna take J, put it here. Because we do use this to account for things. And then, okay. So really, it looks like we just need to modify where we generate the types. So, yeah, in here. So, the collisions. Dang, this might be a little complicated. So we need J. If it's J, it could be any type. So we can have more collisions than that. I think we can do that. So, actually, I think, do we generate the collisions? Where do we generate them? Okay, I could do this, or, and I, K, equals J. So that, let's see, I don't even know what that's going to do. Let me do it on the test input, and see what it looks like. Alright, 66, 32. So, yeah, that's not right. So, still only one pair. Doesn't contain any jokers, so its strength doesn't increase. It's now the only 2 pair. Making it the second weakest hand. Are all now 4 of a kind. Alright, so I should print out what it generates sort of in here. Yeah, this I think will be useful to print out. So, okay. So the rank doesn't really matter. We need the type. We don't really need the current character. So maybe I should print this. Yeah, I'll actually count this out and use this other print statement that I have down here. To see the current type. So, 1, 5. So let me open the test input. Okay, so the first one is type of 1. Which is what again? It is 1 pair. Okay, so I think that is probably still right. Let's see. 3. Yeah, it's 1 pair. Okay. Let's see. So this is supposed to be 4 of a kind. The second one is 5. So I think that is 4 of a kind. Is the 0, 1, 2, 3, 4, 5. 4 of a kind. Okay. And all the rest should be 4 of a kind as well. So one of them is not. This one actually gets rank 4. Okay. So that's supposed to be 4 of a kind. The last one, and it is. Okay, and then this one is also supposed to be 4 of a kind, but it is not considered that. So, shoot, I think I know why, actually. Because we are considering it for both of them. Maybe just for the first one. So, yeah, so I might need to reconsider things. I think the rest is right, though. 2 pair, so 0, 1, 2, is this one. So, yeah, the rest of them are right. It's just with this one. Yeah, so that is... Okay. So, basically, I need to, whichever one has the greatest number of collisions is what J should be equal to. So we still generate the max collision. So maybe, let's see. Maybe I could have a second check. So if, collisions is greater than max collisions, and as I A equals J, then we can do this again for the J. Actually, I don't think that's gonna work. Yeah, I don't think it will. Yeah, 5512, that's not right. Yeah. So that actually just made it farther away from what I wanted. I'll need to think about this. This is interesting. This is actually an interesting problem. Okay, so maybe. Yes, we just add to collisions for J. But then. Let me print F. Collision as well as current character. Okay, and let's see what we get for that. So, yeah, we'll print out a lot of stuff here. So we get J here. Collisions doesn't go up though. I print it afterward to make sure it is increasing properly. Maybe I should print this a bit differently so it's easier to read. But see, if we encounter a J, then it is 1. So that must be a new word. Yeah. Okay, I gotta think about this. So, maybe I should have a second field for J collisions. Would that be helpful? So, I could probably do that. Let me see. So I can have collisions and then J collision. And then if hands I K equals J, then J collisions. Let's equals 1. I'm gonna make a new variable for that. Yeah, in here actually. J collision is 0. Okay. Why don't I just do plus plus here? I don't know. And then yeah, I can do this for J collision. Okay. So that should generate that. And then at the end, in here, can we just add add to the current dot collisions? Collisions plus equals current dot J collisions. Let me see what that does. So, yeah, that didn't work. Did not work. So, and print the current dot J collisions. Let's see what we get for that. J call. So, J call is that. Let me print out the current string as well. Do I have that even though? Current dot the matches. I don't store the string in here, do I? Okay. So what else? I think I can just print out. Let's see. Is there something else I can print out? Do I have something in here? I can print out the ID then. Print.id. That would at least be something. Okay. I changed the wrong thing. So what is this? Whoops. There we go. Okay. There we go. Got it right now. So let's see. So 5. Yeah. So the J collision changes for each one. So that is what the maximum amount of J collisions. So maybe I should do that. So if shoot, I'm saying this the wrong thing. Okay, maybe that would be more correct. Okay, 47. Yes, that's still not right. Let me get rid of the print here. Print statements. J collision for the last one though. We have 1, so that is right. So current type is 1, 2, 2, 3, 2. So yeah, that's not right at all. So, all right, yeah. So, So why is that not? Let me add that consideration and take a look at what we get from that. So we get 1. Maybe I should print out the collisions as well. So that call is that. And yeah, just print current dot collisions, and let's see what we get from that. So yeah, these are the collisions for each one. So this one is 3. And then becomes full house. Is that right? The current type is 2, so 0, 1, 2. So we get set to 2 pair. So, it should be 4, so equals 4. So it should be set to 4 of a kind, which would be right. So, I think maybe. Maybe I should do stack I dot matrix j collision plus equals same thing but j collisions. J dot j collisions. Let's see. Current type is 3, so it did change the types. Oh shoot. Actually, that's right. 1, 2, 3. 3 of a kind. So why is the last one 3 of a kind? That's not right. But it's the right number. So I'm not too happy about that. So that one. Well, so it's right, but it's not right. Current type is 1 for the first one, which is correct. That is what we wanted. And then the second one is 3. 0, 1, 2, 3. 3 of a kind. And it's supposed to be 4 of a kind. Okay, so yeah, it's not getting set right. But we got the right number. Should I just try it? I'm just gonna try it. I don't think it'll work. I'm not taking more time for the print statement, but okay. So yeah, it probably won't work, but I can try. Yeah, that's not the right answer, as I thought. Okay. Just wanted to see. So yeah, I need to get this to be right. So we're close to that. It's just not setting the type correctly. So shoot. Well, I am doing this twice. That shouldn't really change anything though. And it does. So why? Obviously I'm doing it twice, and that's not good. So if I do it twice, then it's the right answer. So that's kind of weird. Maybe I should print this before and after. So, collisions becomes 2. But here's the max. The max is collisions is 4. So, we might need to change this. So maybe we should set it to whatever the greatest type is, because that is where this happens. So 4 is less than type index, and then just make an int greatest with 0, and then if matches stack I. I can't use I here, so I'll just use J. Dot matches J dot type is greater than greatest, and greatest equals this. So I need to just yank that. Okay. Okay. And then we want to set it to shoot, we actually want the index. G index. And then G index equals J. Okay, and we want to use G index here. G index and G index. Okay, and let's see. Okay, Now it looks right actually to me. So 5, 5. So this one is supposed to be 5. K, T, J, J, 5. No. Yeah, that's 5 is 4 of a kind, so that is right. Okay. And then this one is 2. So that is correct. Yes, 2 is 2 pair. Then we have another 5 and 1. Okay. Okay. So that's right now. Let me try it here. I didn't actually look at what the value was last time. But we'll see. Yeah. Not the right answer. Okay. It's too high. So this is too high. I need to keep that in mind. So, yeah, we need to find out what's not working. So, let me see. If I don't print out all this stuff, then you can get a better idea of what's happening. So the current type of the last one is 5. So that is 4 of a kind. Okay, and that is actually correct. Then 0. So that is, they're all different. Okay. And 4. So 4 is going to be 3 of a kind, which is correct. Here's the first one with the J, so that's going to be a bit different. So that's 3. Which is actually, is that full house? 3 of a kind. But this is supposed to be full house, right? Okay, I think so. What is full house again? Where 3 cards have the same label? Yeah, so this needs to, I see. Let me grab this thing and open the test input. Put this in here and see how that gets handled. So we need to change that because, yeah, because it's not being considered as the same. So that needs to be considered. Yeah, so let me open the test input. This is the custom test input that I have. So yeah, it gets set to 3. So 0, 1, 2, 3, which is 3 of a kind, which is not right. We want it to be set to full house because, yeah, it would get like this or whatever, probably on the 8 actually, and then it would get these 2. So why is it not that way? I can print out. I don't know if that would be very useful. Okay, so perhaps it's actually happening. No, not in the sorting because it's just the type is set wrong. Okay, I will print out the ID, collisions, as well as it's actually there we go, as well as the J collision. Okay, and I actually want to print it before we add it. So, current.id, current.collisions, and current.j collisions. Okay, let's see what that outputs for us. Yeah, so the maximum we ever get is 3. So, shoot, this is why. Yeah. Okay, so I need to actually reconsider this whole thing. Okay. Because the match's length is not 2 anymore. Because we have the 1 extra one. Okay. So, how can I reconsider that? Ooh. That is interesting. So if I change this, for example, make these J, then it's going to be identified correctly. Shoot. No, it is not. That's kind of weird. They're all set to 0 though, so I think something's broken. Oh, I set that one to 3. Huh. I have no idea what happened actually. Why are those all 0? Something is broken. What happened? Huh. That is, oh. Yeah, collisions is 3, so should have been set to let's see, this one would be, that one would be a full house, so it doesn't get set to that. No. Huh. What in the world? Let me also print out, I think it'd be valuable to print out matches in. So that is, matches stack by dot matches. Perhaps we could actually subtract from it the number of J collisions. Could that be? Matches length is 2. Yeah, so it should be set to full house, but it is not. It's full house in the right place. That's kind of strange. Let me try doing that. So I need to do that minus current.j collisions. So let me think about that. Do I actually need to just do -1? Because -1 if the current yeah, maybe I could have just int is j equals 0, and then if current.j collisions is greater than 0, then is j equals 1, and then minus is j. Minus is j. And then yeah, that would subtract 1 if there is a j in it. Yeah, so then that gets set to the right type. These are still not right though, so I don't know what this is about. Let me go to the test input and see what that says. 5905, so that's still right. And then the regular input is what? That's probably way too large, because the last one was too large, so I don't think it's right. Type is 0 on that one. Okay, that's actually right. 4. That is identified as a full house, and this one should be as well. So the one right before that. Okay, so that did get identified correctly. So, that is still too high. That is what I thought. So yeah, I definitely need to figure out what this is about, because why are these 0? Why would they, like, this one is being identified as 0. I don't get why. So, so it thinks that it is a high card. But it shouldn't. I could print this out. I'm gonna print a lot of stuff. But I should probably comment out this other print statement though. Right there. And let's see what we get. This could probably, yeah, I could probably set it like that, actually, now that I think about it. Like, just set it equal to this condition, but I'm not going to do that right now. So, rank is 4, type is 4, but then at the end, the current type is 0. No, that's for the wrong one. Yeah, but here, though. So why is that? There it is. Let me print that out. So what is that being sent to? Yeah, why is it 0? Let me actually make this a type. Yeah, I'm gonna have to print it out like that again. Types. Whatever. Types. So it's still 0. What is that about? Where is type index being iterated? Where does it come from? Where did it go? Okay. Type index, so it's here. Matches length. Shoot. I need to do type index plus 1. Okay. That is much better. So 5, so this is 4 of a kind, that is right. And then this first one is gonna be what? 3 of a kind. And it's 4, which is full house. Is it full house? It's gonna be full house, so that is not good. Shoot. Yeah, so that's not gonna work. It's setting ones to full house, that shouldn't be full house. So I need to rethink this yet again. So I can't just subtract that if there is a J. There has to be. Has to be what? Let's see. So this would be 1, 2, 3, 4. So actually, what is that about? Let me add this print thing back. This will give some useful insight, and I don't need this one anymore. Because we got the one problem figured out. So collisions is 2 plus that, so that'd be 3. It'd be 3. So why is it getting set? Why is the current type getting set to 4? Because that would only be here. Unless I am I wrong? Yeah, full house is 4. So, so why is it that it does this? I think I did that wrong. Yeah, I want 2 minus that. It seems to be an underscore. Okay. What does that look like? This is actually... I'll wrap it like that. Okay, now I have some unused ones. So this needs to actually be... I'll just cast this one to an E. Oops, like this. There we go. Yeah, because that should be fine. Should be fine. Okay, and now is it right? Now it is right. Okay, so are they all right? So 3 is not right. Okay, so it doesn't work again. Because this is supposed to be 4. This one was actually supposed to be full house. So where is it at? So that'd be 3. And the match's length equals 3. So actually, I want to subtract it from here. Okay. Yeah, I think that is what I want to do. So I don't know that I need the int anymore. Alright, let me think about it though. I'm quite certain that is how I want to do it. Okay, like this, yeah. Alright, because that would be the length of it, which is 3, minus 1 in that case. So I think that is right. So 4, so 3, 5, 4. This one is, okay. Those are all right then. Let me try it on the regular test input and make sure it's the right number. Still it's the right number. Okay, that's the right number. Now, let me actually look at the test input and make sure they are categorized correctly. So that's 5, which is 4 of a kind, which is correct. This one is supposed to be 4 of a kind as well, which is correct. 2, so what is that? 0, 1, 2. So that's 2 pair, which is actually correct. 5, so that'd be 4 of a kind, which would also be correct. And the first one is supposed to be 1. Okay. Okay, let's see what we get for this. I feel like that's too large. Is that larger than the last one? It's different. I can just try it. That's not the right answer. Okay. Alright, yeah, so it's still not right. I didn't change the data or anything. And the last one is 1000. So we did get it all there. So let me go through some of them. Hi. How are you doing? Primogen, nice. Okay, Primogen. Okay. Yeah, let me go through some of these and see if they are correctly identified. And I already don't... Well, actually, I think that is right. in it. Okay, that is correct. Okay, so these ones should all be right. 4 for 998. 4, 4, 4. So 4 of a kind. No, 4 is 3 of a, no, 4 is full house, which is right. So this one should be full house as well, which is right. Let me just go until 1 is incorrect. So, yeah, let's see. So this one is 996, and that is 0. So they all are different, which is not correct. Okay. Because we have the J in there, so it should be at least 1 pair. I think it becomes 2 pair, right? Okay, let's see. So in here, let's see. No, it's down more. So it becomes 1 pair. Oh yeah, I need to subtract from this as well. Okay, and let's see. So 996 is 1. Okay, now it is actually correct. So, when I can try this again, I don't know if the cooldown is too much. Yeah, I don't know. Let's see. Okay, so I have to wait 3 minutes. Alright. Can keep it in mind. So I can go through and check some more. So 996 is now correct. And all the rest of them should still be correct. 5, 0, 4, 4, 1. So 1 is what wanted, and then 6. So this one, 6. That is actually correct. Okay, because that means 5 of a kind. So now this one, this one is supposed to be 3 of a kind. 3, which is 3 is 3 of a kind. Okay, and the one right above that is also supposed to be 3 of a kind. Which is correct, yet again. Alright, then this one should be 4 of a kind. 992. Which is correct. Okay, I mean, they all are correct, because so far, almost 10 back. Okay, and then we have another 5 of a kind, which is right. Okay. So I might need to adjust the ranking system if this doesn't work, because it looks like they're all being identified correct. So it could just be, yeah, because of the way that we're using J. Alright, but this should be full house then. Which is that one. And the one right before it should be 3 of a kind. Which is going to be correct because of that. Alright. Okay. So, yeah, it looks like they're all right. I think I still need to wait a bit longer. I feel like this isn't any smaller than the previous answer, though. So, yeah. If it doesn't work, then I'm going to have to look into this, because I think this might not be working. Yeah. Because we use the card values, and the card values might not be set properly. Could that be it? Alright, let me see if that'll work now. Okay, one more minute. Okay. Let me see where I'm setting the card values. So, card values. No, just card, let me look at that. So, yeah, where are we setting? Yeah, equals that. Right. I think it should work. Because I put J right there. So that should be the lowest value. It should be right. Yeah. Okay. Has it been a minute? Probably not yet. I will just wait a small amount of time more. Alright, let's see. 8 seconds, okay. Not the right answer. Okay, not the right answer again. So. Yeah, so the rankings must not be correct. Okay. Perhaps I could take just a chunk of this. Maybe like that. That could probably be even enough. So let me open test input and put it in there. I don't want any duplicates, so I got rid of the old one. Okay, so I have that. And then I can print out what we get from it. So it should all be identified correctly. But I want to see, why is that so large? Because I didn't change it. Okay. Need to change it to test. Okay. So yeah, I need to just see if the rankings are all made correctly. So the types should all be right. So if I go to the first one, it is 3. Yeah, which is right. These are all the same ones that I checked. So that should be fine. So I just want to see the rank. So let me comment out the print statement right here, as well as up in here, because I do not need this right now. But I do need probably this one. I think that could be helpful. Okay, so I want to stop here. So this is sorted rankings. So, alright, and these are the types here. Okay. So lowest one is 11, which is the last one. What? No, it's this one. Okay, and yeah, that one is actually supposed to be lowest. And then the second is 8. Which is what type? It is 1. So it is 1 pair. Which is going to be correct. Okay. So far, so good. And then we have 3 that are the same. So this is where we can really figure it out. So the first one is lowest priority, so 1. That is this one. Let me separate it out. So, yeah. Okay, that makes sense, because it's 4. So, yeah, let me just add, like, a comment here. So, 4. 4. 3 of a kind 4. Yeah, so I kind of keep track of it. And then the next one is 5. So, actually, I don't have the right index anymore, so I do this. Alright, so this one is 3 of a kind as well, I think. Yep, 3 of a kind, and it is also 4. So I need to look at the first character of it, and that is, yeah. Alright, so 3 is actually greater than J, so that makes sense. 4 first is 3. Okay, so I'll just expand the comments as I need. First is J, which is less than 3, so that is right so far. Then we have this one, which is 6, so it's the very next one, which is also 3 of a kind. Okay. And it is Q's, which is greater. So that makes sense. So the first doesn't really matter in this case because the Q is greater, right? Or is it only based on the first one? Either way, first is 9, which is greater. So this makes sense. Okay. Then ID of 9 is the next one, and this should be full house. So that is full house. Okay. Full house. And the type of it is 8, then it should be. But yeah, it's full house, so it's greater, so that makes sense. And then first is 8. Okay. Then the next one, 10. 10, which should also be full house. And then that is right. But it's 5. 5 and then A's. But first is A, which is the greatest. So that makes sense. Yeah, that makes sense to be greater than this. Okay. So far so good. And we have 2. I can type. Okay, 2. So this one is full house as well. But the A, and then the first is A. So that makes sense to be greater. Because the first is A, and the next one is Q, which is also greater than 5. So, yeah, it all works so far. Now we have 5, which is 12. That's the last one. Okay, so this one should be 4 of a kind. Which it is. 7, and the first is 7. But it's 4 of a kind, so it's greater, so that makes sense. Okay, the next one is also 4 of a kind. It is 4. 4 of a kind. Okay, 4 of a kind. Which is correct, and it is A. And then the first and second are A, so it makes sense to be greater. Okay. Then, yeah. Then we just have 2 that are 5 of a kind. Wait, hang on. Did I go through this wrong? 7 and 3. So I skipped 1. Because this was the first one, actually, so, yeah. Wait, no, hang on. What is this? So where's 8 at? Oh, yeah, I skipped the first 2, because they are both not good ones. So, yeah, this first one actually is, it is, what is it called? High card. And this one is 1 pair. So they are the lowest, and that makes sense. Okay, so what was this one? So 7 and 3. So 7 is less. So this is 5 of the kind. And the first is J. J. So yeah, that makes sense to be lower. Because this one, the first is 2. So yeah. This one's also 5 of the kind. And yeah, so it's 2s, but the fourth is 2. That's all right. So, uh-huh. So, yeah, I don't know. I'm gonna delete all this. Yeah, so it's right. Uh-huh. Okay, so, is that a different number? It is a different number, so I think something is not right with the spaces. Okay, I must consider spaces to be something. Limited spaces, is it fine? There we go. Okay, so yeah, the spaces confused it. So, huh. Okay, yeah, so as far as I can tell, everything is working properly. But clearly it's not, because the puzzle input is not right. Maybe I should replace it. Replace the input. But it did work, so I don't think I should need to replace it. I will anyway, though. Alright, it shouldn't change anything, though. I don't remember exactly what it was before, but I have a general idea of what it was. Yeah, so they should not change anything. Yeah, alright, so that's the same, I believe. So, yeah. Here's the sorted rankings, though. So, this one is the highest one, 295. 295. So, okay. The first is A. So, but the second is J. But this was the only actual... No. And there was one that was actually 5 per time, right? Before the J was considered. I can find out pretty easy, actually. 7. A. So, if I go in here, and when I print it out, here, I can see what it was on the correct one. So, 344. So, let me look at 344. Oh, but it's all J. So which one would be higher in that case? I'm assuming, actually, that one. So I think that's right. Because the first character in this case is J. So, yes, that should be fine then. That should be fine. And it's 754. And this one is also A. But then the second is J. So, right. That looks fine to me. So, okay. So, what? Okay. Yeah. Let me see. So what is the next one? 232. Same thing. Same thing, but it's K this time. So K is where here? It's the second one. Uh-huh. So that probably would be right then. Well. Maybe. Yeah. Well, yes. That should be fine. So 636. Q. Okay. That's fine then. I'm pretty sure it's all right. But it's not right, obviously. But maybe I'm doing something wrong with the bids. It shouldn't be. Well, this one's T. Okay, yeah, we're just moving along the list. So ID is 503. We can look at that one. Yeah, so these two. This one got placed first because J. Yeah. I don't know. It looks right. One of them somewhere must be getting miscategorized. But it's hard to tell where that would be. So maybe it's one of the sixers. Let's see. This one is ID 450. Yeah, that's right again. But it's the lowest, so that makes sense. So 450 and then 65. That one, okay. 523. Is that okay? 10. So, perhaps some of the ones that are full houses aren't getting categorized correctly. Maybe I could print them out. So just if the type is equal to 4, which is what full house would be. So if rankings I dot type equals 4, because that one is kind of the most sus one. So this will only print out those. We actually have a lot of them. Okay. So I can go through these. I'm going to take a quick break, just very quickly, to use the restroom. And then I will be back and hopefully able to figure it out. So I'll be right back. Okay, I am back. So let's see what we have got. Yeah, so that's obviously not right. But here are the 4 of a kind, or the full house. So, well, alright, these are the ones that are sus to me. Yeah, it's the ones where we subtract it. So 1 pair, 2 pair, and full house. So those are the ones I'm going to inspect. I'll start with full house. So 552 is this one. Okay. That's right. Alright, this is just not affected by J in any way. 521, same thing. So yeah, that should be fine. 582. Okay, same thing again. 35. Yes, okay. 5709. Okay, that one also. 293. Okay, this one has the J, so that should still be fine. I think that's still right. Yeah, because it would be A, so yeah, all good then. What thing was that? 709? 293. Okay, 791. This one also, it just has the 2 there, so that makes it different. And then when we look at 293, yeah, that has a 3, so that checks out. 990. Okay, that one's right as well. 990 is the cutoff there. 166. That's fine. And 708. Whoops, I did that wrong. Okay. That one's fine too. 907. That one's fine, okay. 887. Alright, this one has 1J, but I think it should still be fine. 887 and then 219. Yeah, these are all looking fine so far. let me go to that last one. And which one is it? 219, so 887. Comparing it to that. 7. Okay, so that works. 17. Cacac. Okay. That doesn't start with A, but the rest of them probably don't as well. So yeah. So now we're on to the K. So that makes sense then. Okay. 988. That's fine. 587. That's fine. Alright, these all look fine to me. Like, they're not miscategorized or anything like that. So, yeah. So, I don't know. Did I mess something up in the logic here? I don't know. I don't know. Ta-da. So the bid is that. Yeah, the bids are all set up right still. So I don't know what the issue is. Dot J collision. So you only see the ones with J. So these are all the ones that have J. So 44. So this would be the lowest one. Because it starts with J. So that would make sense. And then 201, it probably starts with J also. And then 464 probably does 2. Okay. 801, I'm assuming. Okay, so 2. So that's the next one. So 103. Yep. Okay. Actually, is that right? So yeah, that's right as well. Okay. 115. They all look right. So I don't know. That one starts with 2, so that's why it's lower, but it's higher than those. Okay. Let me take a look at the 1/3. Let's see that. Okay, here is all of those. So there's actually a lot of these. 880. So these are only the ones with J as well. So alright, so it starts with J. So that checks out. This one starts with J as well. Starts with J as well. Maybe I could compare them also to make sure. So J and then 5 is that one. This is 493, so 306. J and then 4. Okay, so that's less. 880 is J and 4 again. So, okay, 4 and then 8. 306 is T. So T is greater than 8. So, it all makes sense. So maybe it's not one of those problems. Maybe there is something else. We don't have any. There's no 2 pair. So that's kind of weird. Let me print this out. So we get a lot of 2 pair. And then let me also print. J collision. Okay, let's see what that says. Actually, I need to get it from the code. Okay, so we do have some. So something is not right. Huh. We have a lot of them. Let me print out the ID then. It's actually, there we go, size T. ID. Let's see what that says. So we can look at it. So 994. Yeah. That's a 3 of a kind. So, oh shoot. Actually. 2. No. Huh? Oh shoot, I know what it is. Yeah. That's not the final one. It can be categorized as that in the middle. But yeah, we take the greatest, so that's not what it is. So really I need to do it at the end. At the end. So just if matches stat I dot matches G net Actually, I need to actually check it. Dot type. That's what I'm going to do. Dot type. There we go. Equals 2. Then I want to just print stuff out. There we go. We don't have current now, so I have to use, instead of current, I need to do, what I'll do this. Matches current equals matches G index. There we go. And then I can print it out. So, let's see. Yes, there's no J collisions on any of them. It's kind of weird. So, why is that then? Okay, that is interesting. Not a single one. So, I don't really know how to even like check. So if I do AKJ, yeah, well obviously that's not gonna help any. Okay. So. Is this wrong? So that equals 3. Then it's 2 pair. So that means 2, and then we have 2 separate ones. So what is the definition of 2 pair again? Shoot, I can't. Okay. 2 pair. 2 cards share one label, 2 cards share a second label, and the remaining card. Okay. Yeah. So that'd be 3. But we subtract that. So I'm thinking it might not be getting set correct. So this one might be wrong. But I don't really know how to test that. So what would it get set to then if it's wrong? We set to 1 pair, right? Maybe I could check that. And I can just go through it. So 96 is 1 pair. Which is correct. Okay. 986 is 1 pair as well, but it's an A 1 pair. So why is it not greater than? Oh no, that's not in order of grid. So that's fine. Okay. Yeah, so that is right. 983. Alright, so this doesn't even have a J, so have a jack. 1. Okay. T and J then. Okay, alright. They all look right. It's interesting. Yeah, so there's no shared ones there. Okay. I'll keep going through. So 930, let's take that. 930 and 931. Okay, that's actually right. 264T. That's right. 44. Yeah, they're all right. Yeah. So I don't know. I must be misunderstanding something or something like that. Let me read it again. So, read the jack part again. So, white cards that act like whatever card, but it's the weakest. Okay. J cards can pretend to be whatever card is best for the purpose of determining hand type. Okay. But it's still considered J. Yeah. Because J is weaker than Q. Yeah. So that, yeah, that all makes sense. I don't know. Let me go back to the test input and print all that out. Test input. That still is right. 5905. I don't want to do this though. I want to change that. So, it's right here. I'm gonna come down here and print this out every time. And we'll see what it looks like at the end. So here is the sorted ones. This, and there we go. Okay, so 1, 3, 2, 5, 4. 1 is the lowest, okay. Then 3 is this one, is the second lowest. And then, alright, so this gets rank 4. Alright, so the lowest one is, is this one, the Q1, okay. Which is 2. No, hang on, 1, 2. That's this one. So this might not be right then. Because 5 is put above 2. Oh, shoot, no, that's right. Okay, yeah, I just couldn't read it all. It's rank 3, so that's right. Oh, why is that right? Isn't... Oh, T is below Q, okay. Yeah, I misunderstood. So 2 then is... Yeah, it's that one, so that's right. 5, and then 4 is the greatest one, so that's right. It's all right. No problems there. And they are all categorized correctly. I don't print out the type, do I? There we go. The type 1, 2, 5, 5, 5. They are supposed to all be that, and yeah, so that's all right. So I don't know. Nothing is like obviously wrong. Let's go back to the input. Try it again. I think, yeah. Okay. Let's look. Is there something on here? Don't know what a hash map is. Okay. Yeah, I don't want to. I'm gonna look at day 7. Can I just look at day 7? I just want to see. If maybe there's something that that I'm missing. I don't want to look at solutions. I just want to see the way some people approach it. Better example input. That might be helpful, actually. Okay, yeah, I want to try that. So I'll add that to my testing. Yeah, that would actually be very helpful to have a better test. And then, okay, let me run it now on the test. Okay, and that. So part 1 output is that. Part 2 is what? I don't want that. So let me see here. So the first one, that is how it's sorted. Oh, part 2 is supposed to be that. So, so I have it wrong. Let me see if the part, or if the day 1 actually is the same. So I'm gonna just open that up. There goes A. That's test input. Okay, delete all this. Copy this one into there. And try running it and make sure it is right. This is actually very helpful. And I'm running on the wrong thing, so where is it? Right here. Okay, build this and run it. 6592 is correct. Alright, so if I can get it to work with this, so I can see where it is struggling. So what is this about? So that's the sorted values, it looks like. So I can look at how mine is sorted and compare. Okay, this is actually going to be very helpful. So yeah, we are a bit off. So the first one is rank 0. So I can look at that. That is ID 13. So that's right here. Okay, already I'm seeing a big problem. This is not categorized as 5 of a kind, even though it is 5 of a kind. So, shoot, it might be, I think I know why. Close out of that. So if I, that is interesting. If it's equal to 5, then I do that. But it actually gets set to greater than 5. So, there's probably a few ways I could tackle this, but what I can do here is, if code.j collisions, equals, it's less than 5, then do this. I think already that's going to change it a lot, right? So, Now it is categorized correctly. So, okay, 6803. Is that right now, actually? No. So we are off a little bit. So let me look at this one. So first one is that. And I think that's right then. So part 2 is that. Okay. And then J3, 4. So that is what one? 7. Alright, so that's right. So I'm just gonna go through this until it is not the same. So 7 and then 6 is what? Alright, that's right then. And then 8 is this one. Okay, so this is where we're at. 8, okay. And then 10 is this one, so that's right. Then the next one should be T3, whatever. 3, okay. 4 is this one. So that's not right. This one is not right. Yeah, so this one's supposed to go below this one. So what is that one? That is this one up here. Yeah. Okay. So that is interesting. So why is it like that? So let's see. So what is it categorized as? So which numbers are they? So the bid is 13 and 17, so I can figure that out. Bid 13, it gets put all the way there. So why is that then? Bid is 13, ID is 2. Let me run it again because it got a little messed up from changing the window. So right here, it gets categorized as 4 of a kind. Wait, is that right? That's this one. Okay, so why is it, it should only be 3 of a kind. Okay, that's interesting. Ooh. So what about this makes it think that it is 4 of a kind? Huh, that's interesting. Okay. ID of 2. I'm gonna have to go in here then. What if I, take this? Okay. What does that look like? That is very wrong. Yeah, alright, so that is not right at all. 6803 is, yeah, that's the same as it was. So, let me put it back. So, yeah. Yeah, so why is this getting categorized in that way? So this is ID 2. So I'm gonna print out this, all this stuff, and I'm gonna get rid of this for now. Okay, and let's see how. That's not what I want to do. Actually, I want to print out this one. And comment this out. Okay, and you can get a good idea of what we're looking at here. So current type. Shoot, I don't print out the ID or anything like that, and I want to do that. Current ID is that, and print out is stack I dot matches G index dot ID. Okay, and let's see. So we're very close. Okay, current ID is that. So yeah, this goes all the way back here, and the ID is 2, and it gets categorized as 5. So we need to do this. And we can go back to where that one is at. Is ID 2, and see when this happens. So, what is this about? So, 2, so that'd be 3. So that'd be 3. Huh. And the match is length. Wait, so what should it be actually? It should be 3 of a kind. Because the match is length minus that. So yeah. But it doesn't get set as 3 of a kind. It gets set as that. So why does it do that? Oh shoot, 2 and 2 on the first. J goes into 2. Oh dang, okay. Okay, actually, if the current character, do we have a current character? I see what's happening. If I print out the current character, do we have that? It's just at the end here. Let me actually do something like that. Can I just print out the I want current dot Let's see what that says. So current character, yeah, so go back to 2. Yeah, it's J. So what we need to do and current is not equal J. Okay. And then 6839. That is right. So yeah, so what was happening basically is it was J, and it was looking at J, and it was doubling the collisions. Yeah, okay. That is interesting, So now, if I change this, let's see what output we get. This is the output. Okay, let's see if it's right. There we go. That's the right answer. Okay. Okay, that was just a very weird edge case. But finally finished with day 7, so I'm very happy with that. Day 7, part 2 solution. There we go. Okay, so that should be up here now. Okay, making some good progress today. There we go. Yep. So both of them are good. So let's go here. And let me make a day 8. And I want to copy paste from day 7, the build.sh into day 8. And go into here. Make a main.c. Okay, something like this. 0, and let me actually grab day 7. Just grab these things. All of these. There we go. Day 8. Okay. Right here, can paste it in, and there we go. So I should be able to hello world. I don't care, that's not right. Build it, and there we go. Hello world. So let's look at day 8. So I don't know if I looked at this at all yet. But that was very helpful. Actually going to the subreddit and getting the better test input, that helped immensely. Okay. Riding an OCaml across Desert Island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. To be fair, she just had finished warning you about ghosts a few minutes ago. One of your OCaml pouches is labeled maps. Sure enough, it's full of documents, your puzzle input, about how to navigate the desert. At least you're pretty sure that's what they are. One of the documents contains a list of left-right instructions, and the rest of the documents seem to describe some kind of network of labeled nodes. Ooh, this could be interesting. So it's going to be like a graph problem, right? Seems like you're meant to use the left-right instructions to navigate the network. Perhaps if you have the OCaml to follow the same instructions, you can escape the haunted wasteland. After examining the maps for you, 2 nodes stick out, AAA and ZZZ. You feel like AAA is where you are now, and you have to follow the left-right instructions until you reach ZZZ. Okay, let's look at this. So this is AAA. Alright, so this is each node of the network. So what is this? Okay, I don't quite understand how to read this, but okay. Starting with AAA, you need to look up the next element based on the next left-right instruction in your input. In this example, start with AAA and go right by choosing the right element of AAA. Ooh, okay. Then L means to choose the left element of CCC. Okay, CCC, which is that. ZZ. By following the left-right instructions, you reach ZZZ in 2 steps. Of course, you might not find ZZZ right away. If you run out of left-right instructions, repeat the whole sequence of instructions as necessary. Alright, so it's like, that makes sense. Okay, for example, here's a situation that takes 6 steps to reach ZZZ. Okay, so we start here and we go left. So BBB. Go to BBB. So, alright, this is like a map. So, yeah, we can do this with like a hash map probably. Perhaps. Or it could just be like, I don't know, if we need the speed, we could do that, but we're going to go left again, so we go back to AAA, then we go right. So we go to BBB, then we're left again. Am I doing this right? So we go back here, left again, then right, and there we go. Okay, yeah, so that was right then. Alright, that makes sense to me. That makes some sense. So it's going to be interesting to kind of parse this. Let me open the test input. I don't have the test input, so test input and input. Alright, so which one are we, one should be used? I'll just use this one to start. So the first part, until we reach a new line. Yeah, until we reach a new line is the instructions. So, or is the right-left sequence. So, let me try reading this bit. Okay. Actually, hang on. I did this wrong. So I need to actually delete that. Alright, and open test input and paste it in there. Okay, my bad. Alright, so let's open contents. Equals read from file test input. Okay. And I also want to print it out. So yeah, the new line isn't really necessary, but I'll do it anyway. Okay, so then we can read it. So let me just make a global thing. So this will be what? Should it? Well, really, it could just be a 0 or a 1. So I think I could do it like that, where basically I read from it. And then just wall contents I SE4 I 0 contents I does not equal a new line I plus 1. So I'm gonna just go through this in a couple different loops. Yeah. So this will generate the thing. So if contents I equals R, and we want to append a 0. So this can be, yeah, an integer array. RL insts. Yeah, so 1024. So it'll just be like a stack, and we'll just push to the stack. RL len. Yeah, so then just RL inst. Maybe it should be a no, it's fine. RL len plus equals 0. So left, right. So which one should be 0? I feel like left should be 0. Equals 1, not a character. Okay. Else if contents I equals L, then we'll do the same thing, but with a 0. So then, if I iterate over I is less than RL len, or else die, then I will just print out the current character. So RL ints I. Let's see what we get. So I made some mistakes. Because it is not inst, it's just inst. It should be inst, I feel like, because it's multiple instructions. So alright, and let's see. So we get 0 and 1, which is correct in this case. And let me just try changing this a little. So LR. So that should be 0, 1, 0, 1, 1, 0. 0, 1, 0, 1, 1, 0. Alright, perfect. So yeah. This one though is just RL. Okay, so now we have those. We can use those. Just iterate over it repeatedly until we reach ZZ. So for this, yeah. For this one, it's always gonna be 2, right? Yeah. Alright, so there's always only a left and a right. So yeah, this needs to be a string. But it's always gonna be 3. So how could I what's the best way to represent this really? So we have, I feel like it should be an array. Let me think. So if we have an array like this, within it, we could have another array, which has a string here, and then another array of 2 strings. So that'd be kind of complicated, but I feel like that's the way we should do it. So yeah, so it's gonna be 1 array, 2 arrays, 3 arrays, except there's also strings, so it's like 5 arrays. Okay, so it's gonna be character. This is the, sure, okay, something like that. So we know that it's always gonna be 3, but not really for that one, right? And this is the secondary way. This is gonna get a little complicated, but I feel like that would be a good way to represent it. Yeah, unless I don't think a hash map's really necessary right now. Alright, well this can be 1024 because that is like the outer size. Okay, that is the number of these that we can have. And then these, we're always gonna have 2, right? Is that right? And this could be 3. Is that right? Actually, that could be it. It's hard to tell. Size key map. Yeah, so this can start out like that. And we'll 0 initialize the whole thing. So I don't know if that's right. It's really hard to work with strings in this way. But let's see. So we have 1024 potential elements, and each element has 2. The first one, shoot, that's not right, is it? I don't know. It's gonna be really hard to iterate over this as well. Maybe I should do this a different way. Maybe if I used a structure. Yeah. Yeah. Maybe that would be better. So I could make a structure here. And this can be element. So we have this part. So this is the sure. Name. This is the name. Sure. Something like that. And that's gonna be 4 because we'll have the null termination and the 3 characters. And then we have the left. Which is left, which is also gonna be 4, and then the right, which is also gonna be 4. So yeah. That is probably a way better way to do that. So then we just have a collection of these elements. Yeah, so it can just be a single array of these elements. So element map like that. Okay. Yeah, we'll use it as a stack again. So whoops, map then. I think that is enough to represent anything. So yeah, we do this and then we're on to a new line. So yeah, that's all good. So so I feel like I'm gonna try to condense this into one loop. So yeah, so I'll sort of have int lr equals 1, and then if lr, then do this. Yeah, so I just use flags to identify the different states. So this I'll go till its null termination character, and then just if contents I equals a new line, then we'll do lr equals 0. Alright, so actually lr equals 0. So we'll start at 0. We'll do lr plus 1. And we'll use that to go to each different stage. Do we need to go to each different stage? I don't know, but so that we can do that. And then if that, let's say if lr equals 1, for now I'll just set this to 1. And then I can reconsider. So basically what we're going to do is grab 3 numbers. Not numbers. So it's always characters. So that is good to know. So while is alpha, so maybe I should have a separate one as well. Or I could just do this. So while is alpha, contents I, then yeah, we'll just grab that. So we'll make a string here, which will be, okay, and it'll be 0 initialized like that, and then we'll make a len. I cannot speak. And ident len plus equals contents I. So that should get the first one. And then we know that we're going to be at an equal sign at this point. So maybe I would just print contents I. Let's see what that does. It might get stuck in a loop. Okay, something happened here. What is it? So something broke. I need to do I++ here. Okay, so we do get equal sign. So yeah, so that's all fine then. So we know we're at an equal sign, so we need to do, so we are at the equal sign, so we can do I++. That will put us right there, and then we can do I++ again, and we always know it's going to be the same, so that's not really a problem. So that'll put us there, and then we do one more I++. Alright, so we can really just do I plus equals 3, and then we can do the same loop again for that. Okay, and this will get, instead of ident, this will be left equals 0. And yeah, the same thing with left len. Okay, and we'll just replace this, replace ident with left. There we go. Okay, and then we can do, let's see, we might not even have to do I+. Yeah, because that should be on the next one. So we can just take this then and put it here. Whoops, and just replace left with right. There we go. And then at the end, I just want to print out, actually, we have to set the last character. Right. N equals null termination character. Let me minimize this now. And the same with left and ident. So replace this with ident. Oops, I'll replace right with ident. There we go. And replace right with left. There you go. And then I want to print them all out. So this is ident, and this is going to be ident equals, and then left equals, and right equals. Okay. So I will print out ident, left, and right. Okay. So let's see what we get. So that didn't work. That is okay. So I might have to do actually. Why did the ident not work like this? Did not work at all. So yeah, it's set to none. So perhaps what? Maybe I need an outermost. If is alpha, content I. Then do all this stuff. I need this actually. Yeah, that might be a good idea. Yeah, I think so. Oops. I think that is what I need to do here. So let's put that now. And there we go. So that is closer now. So we get AAA, but then we get a comma for let. All these should be right though. So AAA, BBB, yeah. So we got those. But then left is comma. So maybe I need to do. Let me just adjust this. That might not be. Might be why. Okay, but we still get commas. So A. Shoot. Yeah, we get BBB twice, so it's grabbing this one. That's not good. So, BBB and then CCC. Yeah. Because there's a space here. I didn't realize that. Okay. So, at least part of what I need to do. Maybe I need another check. I have to do this. Actually, really have to do that, right? Because we have to account for the space there. Maybe not. I don't know. It's just kind of something. So that was actually right. I just need to do I minus first. You go one too far, right? Alright. Well, so let's see. After this, let me just print the current character. Let's see what we get from that. Okay. Always on a comma. So whenever we print it, we get a comma. So here's the comma. Why is it there? Let's look at this thing. So then we have D. So yeah, we go way too far. Why is that? Actually, so that's A. Okay. I think I need to check each time. So really, I could go here. Close this. No. I don't want a lot of nesting though, so I feel like that's not. Okay. Content. So let's do when is equals 2. See what that gets. What that gets us. So that's still A. So yeah, we're at the end of A at this point. So that's right. That's what we want. So right at the end of A. When you do minus, then we're the first part of A, yeah? Yeah. Okay. And if we don't do minus at all, then we are at a space. So we do this now. Where does that put us? That puts us at the open there. So I need to do 4. And okay, then we got BBB. And then we need to do this, except right here. So I think we need to do plus equals 1 or 2. So, we get that. So, the mean to I plus equals 2. Okay, there we go. That is more like it. So A, I can get rid of this. We have A, B, and C. B, D, and E. C, Z, and G. Alright, and let me get the actual input and make sure that everything works. All of the parsing and whatnot works. This can just be input. Okay. Alright, so we print all those out. Okay, maybe that was a mistake. But, so 0, 1, 1, 1. So that is left, right, right, right. Alright, yeah, so I think that's all working. And then this, the last one, GHG, GHD, DHG, DXX. Alright, yeah, so that looks like it's all working. So let's go back to the test input. Okay. So now we are generating. Should be generating the whole thing. So instead of printing it out, we have to create a new element. So element elem equals, and so dot equals ident, dot left equals left, dot right equals right. And then we just want to append that to the stack. So this is map map when plus plus equals something like that. And let's see. So that's not word. Shoot, it's an array, isn't it? Yeah. So I need to do like mem copy. Yeah. For 0. Then I can just mem copy elem dot name ident and 4. Do the same for left and right. And with alright, that's actually not good. Right and yeah. Right and left. Okay, let's see. That should work then. So now, if I don't print things out, so what this is printing out the contents. I don't need to do that. If I iterate through the map line and print out, name is that, left is that, right is that, and print map I dot name, map I dot left, and map I dot right. It should print them all out. So there we go, and that is the map. So now we have that. So we can iterate over it. And we need to we need to be able to jump to it. So we can make a function that is like find in map. So this is sort of like a hash map kind of thing, but we don't need to use the hash map unless it's too slow on the actual one. We can restructure it to use a hash map, but for now we don't need to worry about that. Find your map. So yeah, whichever one that we're looking for. So we'll say left. I mean, it should exist. So if we just pass that in there, so that's just gonna be a string. So let's make that. So yeah, this is gonna return probably the index. So find in map, and yeah, we'll take a string, and then we just need to iterate through the map and find the name that is equal to the string. Equals 0 while I is less than map length plus, and just if string compare string and map I dot name equals 0, then return I. So let's just print f find in map. Find in map, so we don't want that. Let's just try to find ZZZ, for example. Okay, something like that. And let me actually put it after this. And it should return the index of that. Oh, because that returns an index, so there we go. And let's see. Control reaches that. Otherwise, yeah, otherwise we'll return it. It should be an 8. I don't know. Otherwise we'll just return 0. That might not be good, but it should be fine. It should always be in the map. So 6 is the index. Which is what? That is right, because it starts at 0. So 0, 1, 2, 3, 4, 5, 6. Okay, and if you change it to GGG, it'll be 5. So there we go. We have the find in map function. So it kind of works like a hash map that doesn't have the hash. Yeah. Okay. So basically, we need to look at the current left-right instruction. Okay. So I can make like an int cur inst equals so we can start with what? Yeah, we want to start with left right is 0. And then also we want inst index. I'm gonna start at 0. And then if inst index equals let's see, lr, how did I call this? lr len minus 1. When it equals that, then we want to set inst index equal to 0 again. And we'll start over. So that is how we'll grab it. So actually, we can set the current index equal to this, equal to the inst index. Something like that. And then, so that is whether we choose left or right. So then we can do if cur inst equals 0, then that's left. Else if cur inst equals 1, and that's right. Okay, and then we'll just grab that. So we'll find in map. Shoot, actually we don't want to iterate over the map like this. So yeah, really, let's make a while true. And then we'll just have a break once we reach Z. So this might run forever, if I don't do it right, but that's okay. Find in map, the current, so we'll need an index for that as well. Shoot, no, we just want to start at the 0th index. So, so we want a current. So we'll make a current, yeah, it can just be cur 4 equals, map 0. Okay. Alright, but we don't want to, we want to do that here. And we can change the current as we go. So, current equals map, find in map, so that'll get the index, dot name. Yeah, okay, find in map. And so if this is the case, then we want the, current, no, that's not what we want. We want the current to be, an element. Current equals map 0. Okay, and then we can set current to that. So, I want to find either the left or the right. Okay. So yeah, map, or no. Find a map, current dot, this is left, and then this is going to be right. And then, just at the top, we want to check if current dot name. We actually want to string compare. String compare, current dot name, and ZZZ equals 0. Then we just want to break. Printf win. And we'll need a counter to keep track of it, but this should reach the end. So let's see what are the errors. I is undeclared, because we don't have I anymore, so we don't need that. LR len. Alright, I did that wrong. It's RL len. As well as LRL links. Okay, so I can cast this to an int. There we go. And we need standard bool. So why is that? Oh, because I use wall true. So this seems to be wall 1. Fine. Okay, so this one is actually, it's gonna be size 8. That's fine. So I don't have to cast it to int then. Casting int to an int. That's interesting. All right, let's see what happens. So it's running forever. So that's obviously not going to work out. So why is that? Current inst equals that. Shoot, I don't change the inst index, do I? Inst index plus plus. Alright, let's see. So that should change it then. Win. Okay. So we did reach the end. Let me make size t counter equals 0. Should start at 1 actually. It should start at 1. And we can do counter plus plus here as well. And let's print out the counter. So count 2. Alright, 3. So for this one, 2 steps. Okay, so maybe it should start at 0 because, yeah. 2. Okay, and then let's do it on this one. So let's just, maybe I'll make the test input this one. Test input .txt. Open that up. Test input. Paste that in there. And we'll read from that file instead. Let's see, so it should be 6. And it runs forever. Okay, that's nice. Let's see. What is wrong? So test input. That is this one. Could it be reading wrong? Let's print the inst index. And let's see, I'm assuming that's not going out of bounds. It doesn't matter. Okay, yeah, so that is being reset properly. So let's print the current.name. Let's see where we're jumping from. So we go between A and B. So yeah, something is not right there. A and B. So we should go left, so it'll take us to B. And then we go left again, so it'll take us to A. And then we go right, so we end up at B. We go left and back to A, left again, back to B, and then we go right, and that ends up at Z. So that doesn't happen. So maybe, actually, does this need to be like that? I don't think so. I think that's going to go out of bounds. No, okay. That is actually right then. And let me go back to the first test input. And that's right. Okay. So let's try it on the input then. See if it gets stuck. Might need to. Oh shoot. That's not good. I don't want to print stuff out. Because that is slowing it down and also like crash my computer. So let's see. I feel like it's stuck. But it's also very large. So, and we're not using a hash map. I might want to use a hash map. It won't be that hard to implement one. And I do have my own, so it's not like I'm taking someone else's code. Yeah, but I'll see this. How long should I try to run? Maybe I could have something that is sort of giving an update. It's really easy. It's here. Yeah, it's kind of hard to tell. Like, it's kind of hard to tell what you would do with this. Yeah. I feel like it's not working out. What can I print out? That's not on every iteration. Maybe I could check this. Print that. So each time we encounter this, we'll print out this. I might still print a lot though. Yeah, that is kind of a lot. Let me actually make a new terminal. Okay, and let's run. Yeah, it prints out a whole lot. I feel like it's all different stuff though. This is also slowing it down a lot, but yeah, should I? Maybe I'll try to use a hash map. How much? They would make it a lot faster though. I do have. Let's see, hash map. This one. I could probably. It's just a header only one. I can see if I remember how to use it. Yeah. So if I just grab that, I'm gonna try this because it might just not be working, but it also might just be too slow. So yeah, now if I just include attachment.h, and also I need to define a thing at the top, which it says here. Shoot, actually, I think, did I grab the wrong thing? Attachment.h. Yep, that's not what I wanted. Okay, remove attachment.h. Okay, I forgot you have to do this stuff. There we go, the raw. You gotta take it raw. Okay, that should be better now. So now it should be attachment.h. Okay, that's good. I might have some conflicting names with it as well, because I call stuff map. Let's see, what do you have to define? Maybe you don't even have to, because I think I made it wrong, but hash map implementation. Okay, sure. Hash map implementation. Lenny Eric followed? Thank you, I appreciate that. Alright, hash map implementation, that should be good then. And then, should be able to use it. So let me make sure it compiles. It does not. Because this is actually quotes. My bad. Okay, now compiles. So, I put a map and get from map. So I don't think that actually conflicts with anything. It might just be this does. But if I don't call it map, it should be fine. So I can initialize a map here. Hash map, that's what I'll call it. Equals. So I'll allocate it. Yeah, I'll allocate it to the heap, sure. And I'll probably free it at the end. I don't want to do that. Delete and free map. Sure, I'll do that. Just why not? Alright, so we want to insert into the map. So how does this work again? So we can get from map and put in map. So we want to put in map. Alright, so then the element would have, yeah, we don't need the name anymore. And then the name could be used as the key in the map. So really at the end here, we just want to put in map. I'm gonna need to increase the hash map size as well, otherwise it's just gonna be really slow. So yeah, put in map. And what the key is going to be one.name. So actually, let me do this. I'll use ident actually. So I'm not gonna remove it yet. And we just want to put element. Okay. We need to pass it as a pointer though. And I don't think it's gonna exist anymore because it'll be on the stack. So we're gonna need to allocate it, but it might take up a lot of space. Let me allocate it. What is the value type of the hash map? It's just an opaque pointer. Well, it's like a structure that I have in here. It is, yeah. It's this. It's a map, which is made up of nodes. So it's like a linked list. That is the type of it. So I'll allocate this. I think I can do it just like that. Alright, and then it should be fine. I'm not going to free it all, but it'll just free at the end. Hopefully it doesn't use all my memory. I don't think it will, but affected map, but arguments of type element. So, it's not called that, it's called hash map. Okay. Yeah, this is also hash map. Okay. Yeah, because it needs to be a pointer. So, there we go. And then this needs to be like that. I probably shouldn't copy the name of it, since we're not using that. So the name will be nothing. I need to equals. So that's gonna copy it, but that's okay. So that could probably be pointers, and then it would be more efficient. But shoot, yeah, I need to do that. That's it. Right. Okay. Yeah, it goes forever because I don't actually take account for it. So instead of that, we can find in map. So yeah, instead of finding the map, we'll use the get from map. Okay. We need the name in there actually still. So, but we could use the key, right? Okay, well, so what we're gonna do is current equals, so how does this get from map work again? Okay, yeah, so it returns like a pointer. Current equals get from map. And so, yeah, the left is the key from it, so that'll be fine. Get from that. And then the key is current.name. Something like that. I think this will work. So I did some things wrong. Because it's not map, it is the hash map. Okay, and yeah, because this is, so I need to dereference this way. Actually, no, that's not going to work. Because you get from it, no, that should be fine, actually. Yeah, we don't check for null. I don't think we'll need to, but yes, then I need to actually cast this to a pointer of element. And then dereference. Okay. Let's see what happens now. So we segfault. Yeah, let me go to the test input. So I probably messed some logic up, and that's okay. So it's probably when we're in here, trying to get from map. But we also have current.name, which doesn't exist anymore. So that is actually part of the problem. So for now, I'm gonna do that. All right, so it's still segfaults. Let me see. So we're still placing in the map. It just should also be in the hash map. So we won't really need this greater map. GDB time soon. If I cannot figure this out, then definitely will be GDB time. But I'm gonna try just some print segments first, because I think I'll be able to get enough information from that. Maybe not though. We do current.name. So let's see what we get from that. Okay, obviously that's not right. Oh, that is interesting. So something got very messed up. But that's after we set the current. So I was showing you that before that. So so this is actually not working. We can't really check that. So maybe element 10 equals this. Yeah, get from out. I'm not gonna cast it in this case then. And then we can check, whoops, semicolon. If 10 equals null, then assert false. So I'll see where it fails at. And then I can just set current, whoops, current equals 10, like that. And I can do the same thing in here. Shoot, actually I'm not setting it equal to the right thing. Yeah, because this is not supposed to be current.name, it's supposed to be current left and right. So that's not right already. Okay, and there we go. Let's see what that does now. Extend bool. Yeah, I can just assert one. Okay, let's see. So, same thing, yeah. Might need GDB. So it's not null. We are getting that, but it's not being set properly. So it is found. Shoot, let me increase the size of the hash map. I think hash map size is what I need to define. I can look. 8. Hash map size, yeah. So I'll just make it like pretty large. Okay, yeah, that wasn't the problem. But that's gonna make it a lot faster once I do get it working. 1 is equivalent to true, right? Yeah, 1 is true. Well, anything that's not 0 technically is considered true, and 0 is false. That is how it is handled. I could put 69 in here, and it would be the same thing. Yeah. Typically, you would use either 1 or -1, though. Yeah, like standard. So yeah, why is it set false? So it's after this that it actually set false. Because it's being set to the incorrect thing. So perhaps it is when I'm placing it in here. Put in hash map, element. Maybe the element doesn't exist anymore. Maybe I could just use use this. Use this array rather than a whole map. Would that be good? Like, and just use the hash function. I don't know. Maybe not. So let's see. We passed the element in there. Let me put that element or elem and just see. Ooh. Okay, so that's all right then. But yeah, maybe I want to use GDB. That might be a good idea. I'm probably just doing something really stupid. So we're not removing anything from map. Oh shoot, I don't initialize the map. I don't think it's really necessary, but I should probably do it anyway. Okay. Yeah. So that didn't change anything. Maybe the put in map is failing. So I could check if put in map not equals 0, then assert 1. So that'll be true. Shoot. Oh shoot. I see what you're saying now. I was doing it false. Or I was doing it wrong. I see. Okay. Yeah, there we go. Thank you for pointing that out. Yeah. I was just not thinking right. So 117. So that is this one failed. Okay, so it is null. It does get placed in the map properly. Maybe it's not being allocated properly. Well, it should be, because it's not like any pointers or anything here. So that should really be fine. We mem copy into there. So maybe I could try doing this on the outer part. There we go. Temp, get from hash map, and instead of this, I'll just do AAA, which should be in there. Yeah, if I did it right. And then that's probably gonna fail. But current does not exist, so let me just not do that. Assertion failed. No. So that one did not fail. So, So current.left does not exist. Let me put that. Current.left. Let's see what it says. Okay, current.left is not right now. So, that is interesting. Let me print current.left here. It's BBB, but then when we are in here, on a different iteration that might be, it is all wonky. So that is interesting. So yeah, okay. Current, maybe current is not, maybe this doesn't set current. Maybe that is not the right way to do that. So get from hashmap just returns the pointer to the value. On the first iteration, cur is set to map 0. Is that correct? Does map still contain? Yeah, it does still contain values. I still put it in there. I'm probably gonna get rid of that, obviously, once I get the hash map working. But for now, I'm just initializing it to that, to start. But then I could start by initializing it to this. But it does contain values. You can see I'm still placing it in here. And that is really the only thing that works, because when we print it out here, it does that. And then we go through one of these, and it stops working. So that is, yeah, that is the issue. Maybe it cannot be, maybe the current one could be a pointer even. Then we could set it to right. Pointer to map 0, so this has to be one of those. Like this. And then we could just set current. Like that. Yeah. Like this. Whoops, like that. Right, okay. Okay, so something like that. And I think I'm probably still, yeah, like right here. Alright, let's see. Yep, current.name needs to be that. Okay, and it still doesn't work. But now it is cleaner. So, can I cast this? This shouldn't do anything. If I cast it to an element pointer. Yeah, it shouldn't change anything. Yeah, because the cast is just for typeset here. So, at what point exactly does that happen? So this one actually works properly. And then, let me print, temp name. And it should be AAA. And it's not. Okay, so it's not being stored in the hash map properly. So, did I do it wrong? This is wrong. Okay, there we go. Yeah, I was passing the pointer to the pointer. And that was creating an issue. Okay. Yeah. That was just a stupid mistake. But, so this actually did work now. Let me go to the, that is the test input. Let's go to the test input. So this one should be saved. Okay, so let me try to get rid of any of the map stuff, because we don't really need that. We shouldn't, at least. And we can just start on AAA, because I think that is where we start. No, it's not. Yeah, so we want to actually start on the first one. So, we could just make like a variable for the starting one, and set it equal to whatever is first. Maybe. Because we don't want to start with AAA. Okay, well, let's see. Let's see, so starting ident. And yeah, so I can just do this like starting ident 64. Do that. And then I can just mem copy in there. So then this is just starting with 0, and then 1. And at the end, I'll just do if starting, then starting equals 0, and it won't be true anymore, and then you can just mem copy, or stir copy rather. These could be stir copy as well, but it doesn't matter. And we'll just put starting ident is ident. Okay, something like that. So that probably isn't quite right. Starting ident. Did I not define it? Ident, not index. Okay, and let's see. So it failed. Right here. Okay. So yeah, that broke something by doing that. So starting is AA, which is right. But then this failed. So let's look at temp left, perhaps. And right. Okay, so I don't know why this would break something. Do I still use the map anywhere? Let me comment out the map. I'm not gonna get rid of it yet, but I will comment it out. And then let's see. Whoops. Did not mean to do that. So yeah, map is undeclared. Shoot. I forgot to actually reset this, or get rid of this rather. So this should be occurring here. Okay. Temp is undeclared, so this needs to be occur. Okay. And this needs to occur as well. The map is undeclared, so I'm still using that. That's in find in map. Okay. I don't necessarily want to get rid of this yet, but I will do that. Okay, let me turn it to stir. Whatever, that's fine. Okay, there we go. So now it did work. Okay, so yeah, that was I know what is happening there, but okay, because we're setting it equal to the first element that didn't exist anymore. So that problem actually did come up now. Yeah. So now that works. Hopefully it is faster. Like I should have saved the last one to make sure it was. Let's look at input now. I'm gonna print a lot of stuff out though, so yeah, let me get rid of the print statements. Hopefully it is faster then. So we don't we do want that last one, because that is the end part. We don't need this, and we don't need this. We can print out the starting event to make sure that's right. XQN. That is not right at all. So where is XQN? Oh, okay, because we print out the right. Okay. That is right. Okay. So now it's running. I don't know. It might be incorrect logic. Yeah, and I don't know what exactly to print out to test that. To test that it is at least getting closer. It's really hard to tell though. Also, is this right? I probably should have checked that. Alright, I'm going to end it quickly and just make sure that is right. Which is pretty easy to check. Next. I++, and just print out. Whoops. Yeah, print out %d. Actually, I also want to print out the index, so int index goes here. I don't need to do it on every iteration, but I'm going to anyway. And then I want to just print out RL inst I. And let's see. Index is not declared. What is it called? RL. That is what it is. RL length. Okay. So let's see. Alright, that is right then. So 263, let me just make sure that is the right length. Okay, perfect. So that did work then. I can just leave that, that's fine. Okay, now I'm gonna actually let it run. I don't even know if it's any faster. I might need to actually increase the size of the hash map. How many do we have? Only 764. So that should be large enough. Should I print the hash map? And just see what it looks like. I kind of want to make sure everything's set up right. So let me try that. Because I do have a thing to print the hash map. So I'm gonna print the name instead, so it's not confusing. I'll get rid of this. I'll just print. Let's see. I think it's print map. Put hash map in there, and then you also have to print what the types are. So that might not even work. Yeah, it might not work. These comments are all weird, but okay. Name of map, and then the symbol for printf value. Yes, we can't really do that. Because it's not a traditional value. It is one of those. I don't think there's much I can do about that. Shoot. Okay. I can just iterate over the map and print it out. Because it shouldn't be too large. So what does it look like? I don't remember exactly. So yeah, we have so map.hashmap. And yeah, so it'll just be hashmap size. Hashmap size, plus, and then I can just actually copy the print map function. Yeah. And just sort of do this. So there's gonna be some weird stuff in here because it's a macro, but that's okay. So I can just get rid of those at the end. Okay, yeah. And then I'll be able to print it out quickly. So node key and then node value left and node value right. Yeah, it's just a custom print function basically. So we put printing type in here. We don't need that because it's not a macro anymore. So yeah, and then left is set s, right is set s, and then yeah, it just continues on from there. Okay. Let's see. So that's probably not gonna work yet. This needs to actually be hash map. And okay. So expecting that before node. Where do I do that? Right here. Yeah. Because that's just the casting. This is actually a char star, so okay. Shoot. What? So that's not gonna work. I don't think I need to cast. Do I need to cast it? I don't think so. Okay, so I do. So I'll cast it to an element. And that should still work. Okay, how do I do this? Yeah, okay, so that is a node. I can just set, that equals, actually I could do current, okay, yeah, okay, I think, I can try it. Thank you. So, that element pointer, okay, let's see if that works. I think that is right then. Do I need that one? Yeah. No. Girlfriend's blueprint. Okay. Let me just make sure I... No, shoot, I did that wrong. I need to be like that. Okay, something like that. And, alright, perfect. That did work. So thank you for that. Okay, and it did actually print it out. So I just want to see what it looks like. So how many... Yeah, there's not too many collisions here. Yeah. This one has quite a few, but it's not too bad. Yes, this is going to be 1024 then. But yeah, that's pretty reasonable, I think. Most of them are around 2 or 3, or, well, I guess most of them are around 2. And then there's some that go to, like, 8. Yeah, but that's not too bad. There's not too many. Could maybe even try out a different hash function, but I think that'll be fun. Yeah, so that should not be an issue. Yeah, I spent all that time for that. I'm just gonna comment it out. May be useful in the future. Okay, I should still work then. So yeah, there we go. So that's the starting. So now I'm just gonna wait and see if it works. Because it should work. Let me read it again, make sure I did it all right. Yeah. Maybe I could also do like just to get a second part of this, just if counter mod 1000 0 something like that, then print it out. Maybe even 10,000. Does it get that high? Maybe 5,000. Then just like print F. Should I print the counter or the name? Maybe both. Counter is that. So I'm gonna have to stop it again, but just one more time. Counter and then print name. Alright, so let's see. Oh shoot, that actually is way too much. So 50,000. I wish the halting problem wasn't unsolvable. Then we could prove whether the code terminates. I don't know what you mean. Yeah, it still prints a lot. Might get too large. Okay. Yeah, that's getting pretty large. It's also just slow it down a lot. Okay, maybe just every 5 minutes. Okay. Yeah. It does move pretty fast though. So I might be doing it wrong. How large is this now? 9 digits. Okay. Yeah, what is I don't know what the max is. But it's quite a bit, so I'll see if it overflows as well. Okay. Let's just look at one of these. So ANP, sure. Is which one? ANP equals. So yeah, it's here. It doesn't really help though, because that's not. Yeah. Mhm. Okay. Uh, yeah. Maybe would require stopping. I could compile it with optimization, maximum optimizations, and maybe it would be even faster. It also might break stuff, but I don't know. I don't want to stop it now. It's going kind of slow. Let me make another one. And just see if it's a lot faster. Actually, that probably just broke it now, because unless the whole thing's in memory, I'll just stop. I'll stop. Whatever. Shoot. Okay. I don't know if that's any faster actually. Let me actually make sure. Okay. Yeah. I'll just let it run now. Actually, I'll actually let it run. Yeah, I stopped it when it was quite far along, so maybe I shouldn't have. But okay. How large does it get? That's a pretty big number. It's gonna be there for a while. So. Mm, is yeah, what is the this? Yeah, that's what I would like to know. Size max, yeah. What is it? I'm gonna print it out. This. Okay, so that we got wait, quite a bit. But I don't know if it you know, I feel like it might be wrong, but also I don't know. So there's only one place, so it's NGC. So we have to be on that one and right. That's supposed to take that long. The admin and code problems are usually designed so they can be solved quite quickly. Yeah. Yeah. I mean, one of them, the day 5 one, the part 2 of it at least, it took a while, but that's because I did it in a stupid way. But yeah, it's probably not right. What if? Yeah, why? All the test input works, so I don't know. I don't know. I need like a secondary test input. It's kind of hard to generate one because of the nature of it. Maybe I could just extend this one. Extend that. So let's get rid of this one. Yeah. It's really hard to tell when that happens. So H. Okay, let me try that then. And I have to place all these. This will actually. Okay, I guess I could do kind of random. Well, I don't know. I want it to be solvable, so actually I don't know. I don't know. Yeah, I don't really know how to generate them, so. I don't even know if it's solvable. I can find out. So one of them actually has to go to Z, so sure. Okay, is that we do have actually we have some unexisting ones and I forgot to account for that. So we need to it stops. So let me just loop back over. So I'm gonna make it loop forever. Yeah, something like that. And the last one be Z. Okay. So I can try that. We'll open a new one though. And okay, so let's run it. I don't want to edit this. To the main two, so I don't interrupt when it's running. Oh yeah, that's because I have it open currently. So yeah, it's gonna cause weird problems. Whatever, it's fine. Okay, yeah, I just want to edit it so that it is test. Okay, and build it, then run it. Yeah. Shouldn't actually enter. Yeah, I know it shouldn't, but I just don't want to risk it. Just to be safe. Yeah, this one probably isn't solved. Probably just loops. Because it's not very long. Actually, it's not even on the right one, so it didn't even work. Let's type in. Oh shoot, still I run it on. Shoot. Okay. Let's test. Wait. Oh shoot. Yeah, this one is right here. So I'm just gonna change this to the sure. Recompile it. There we go. And then it gets stuck on DDD. So that, yeah, that doesn't work. This one will go back to B. Sure. Actually, I don't know if you can continue with that. So maybe this one will go to the P. Yeah, and then it looks like it gets stuck in a loop. Okay. Maybe I'll add some more here. Actually, that won't change it. So, like that. And that gets stuck on E. Because E loops, yeah, so I don't want it to loop to itself. So, yeah. It still gets stuck on E. Why does it get stuck there forever? Does L go back to E? So, then it gets stuck on N. Alright, that's kind of weird. Why does it do that? This could be not right. Okay. What if we just go right to, and then it should finish instantly. Yeah, okay. Why did it take 4? So we went there. Oh, because we went to the right first. We went to the left, and we went to the left. And right. Yeah, so that one worked. What about one that links to P? Does any of them? None of them do, so that is a problem. LE. Okay, so LE. L. Why does it go to E? Oh, LEM. I didn't even see the M. Okay. Yeah. This one must be something different. It's stuck. Yeah. It's hard to make these. And that's still going, so it's hard to tell. Hard to tell. Actually, let me change one of the ones. I actually got the. So I'm gonna bring it back to finish. No. Yeah. I don't know. Oh, okay. I want to finish fast actually. Okay. Could actually be the case that you're always supposed to start at AA and not at the first line name. Ooh, that could be the thing. Oh shoot. Starting with AA. Maybe. Oh. That's an easy change. That is good thinking. Let me try that. So I just thought that one, but okay. So if I just change this to AA. Looks like, yeah, I saw it. So let's see. So wait, let me just make sure it started at AA. Did not. That is correct. Okay, so that is correct. Thank you for that. I need to modify this again because it is main 2. I don't want that. So let me actually just remove main 2, build it again, and run it. And on the wrong input, so that's not gonna work. There we go. Okay. All right. Thank you for that. I just assumed you would start on the first one. Okay, and hopefully. Okay, perfect. Thank you. Yep. Okay. I guess I should have read it more closely. I do have to go now though, so I will commit these changes. Quit that. Okay. Let's see. What do I want to? That's all good. Okay, very much A. So yeah. A8 part 1C. Okay. Alright, yeah, so I will tomorrow work on part 2. Yeah, so thank you for watching, and thank you for everyone that helped as well. Never make assumptions in these puzzles. Yep, that is a good idea. Yeah. Now I know, yeah, so see you guys next time. Goodbye.